Good morning, students. Today I am going to teach you line, surface and volume integral. Okay. So before seeing about it, first we should know what is point charge, line charge, surface charge and volume charge. Okay. So basically charge, okay, it is denoted by a plus symbol or minus symbol. If it is a positive charge, it is denoted by a plus symbol. If it is a negative charge, it is denoted by a minus symbol. So basically, if a charge is accumulated in a single point, it is called as a point charge. Okay, and what is line charge? If the charge is distributed towards through a line, okay, then it is called as line charge. And surface charges, if the charge is spread over a surface, it is surface charge. And volume is if a charge is occupied, if a charge is occupied by a cubic shape or a shape, then it is called volume charge. Okay. Now, what is charge density? So, how dense it is, how populated the charges are. So, it is defined as, so there are three different types of charge density. One is line, surface and volume charge density. So, line charge density means per unit length how much charge, so total number of charge per unit length. So, if this is the length, so for example, if this is 1 centimeter, how much number of charges it is occupied in this particular length. Okay, that is the line charge. So total charge divided by total length of the charge. Okay, so the unit of the line charge is coulomb. Basically, the unit of charge is coulomb per meter. Okay, and surface charge is the same as the line charge. The only difference is total surface area. The denominator will have per unit area. Okay, so the unit also like this, coulomb per meter square. Volume charge density here per unit volume. For unit volume, how much charge is occupied. So that is, the unit is coulomb per meter cube. It is meter cube. Okay, now let's see the charges one by one. So first is point charge. Okay, so so this is the point charge. So that is in a particular point the charges are accumulated. Okay, so for that point charge, what is the E? E is electric field intensity. Okay, so electric field intensity with respect to the charge is nothing but Q divided by 4 pi epsilon r square into that direction. Since it is a vector, electric field intensity is a vector, we will denote it with the base vector or unit vector A or 1, 2, and it is the electric field intensity is nothing but the charge per unit length. Okay, so sorry, unit area. Okay, so this is the electric field intensity of this point charge. Next is line charge. We know what is line charge. The charges that are distributed over the line or a length of a conductor or anything. Okay, so in order to analyze that full length, we will consider only a small length. So take this differential length as dl. Okay, let this be dl and the total length of the conductor or the line will be L. Okay, so if we analyze everything in dl and if we integrate over the whole length, we will get the total electric field intensity for that particular conductor or wire. Okay, so first basically what we do is, first we should know the charge. Okay, we cannot find how much charge for the entire length. Instead of that, we will find the charge of this particular differential length. Okay, so that is dq is equal to, what is dq? So from this you can easily derive dq. So you know that total charge is nothing but q divided by the length. The length of the charge is L, right? So from this you can derive q is equal to rho L into L. If q is equal to rho L into L, dq is equal to rho L into dl. So instead of L, you should put dl. dl means differential length. Okay, and one more thing point P. Okay, the electric field intensity because of this line charge at point P. Okay, how will you find that? E is equal to, we have a formula, just Q divided by 4 pi epsilon into R square. Okay, so instead of Q, we will substitute this integral of rho L dl vector. Okay, and the remaining things you have to write it as well. That is 4 pi epsilon R12 into A R12 vector. Okay, so this is the electric field intensity of line charge. Next is electric field intensity of surface charge. Okay, so let's draw the surface. Surface, that means the charges are distributed throughout the surface. Okay, so from this surface, let's take a small differential surface ds. So this is the entire surface, and let's take a small differential surface ds. Okay, so similar to the line charge, we try to write the dq. So here dq is, for line charge, dq is equal to rho L dl. For point volume surface charge, dq is equal to rho s ds. Okay, and again, what is ds? Okay, let us consider the surface charge is distributed in the z direction. We know what is z direction? The normal direction is z. Okay, so if it is z direction, we know in cylindrical coordinate system, what are the components? dr, r, d phi and dz that we have seen in the previous class. So if it is pointing towards z direction, you shouldn't consider the z. So you should directly multiply dr and r d phi. So instead of rho s, we can ds, we can write rho s into r d phi and dr. Okay, so we got dq. From this dq, we try to find q. Q is nothing but the integration of dq. So if you integrate, you get like this again. So everywhere the procedure is same. First try to find dq, then from that q, and then from that e. Okay, so this equation, so we have got q, so substitute q in this e, electric field intensity. So we get E is equal to, so instead of q, you will substitute rho s ds, and the remaining things are as it is. Okay, and next is volume charge density. Okay, so volume charge means throughout the volume you will consider a small differential amount. Okay, so this is the entire volume. From this we will consider a small cube having a volume of dv. Okay, so the volume of this particular portion is dv. Okay, then the steps are similar. First try to find dq. dq is equal to, if it is a volume charge, then we will say dq is equal to rho v dv. Okay, so to find q, you will just integrate it. So integrating, after integration, you will substitute q in e equation. So the electric field intensity is equal to integral of rho v dv, and the denominator